Hello, this is Mr. McGovern, and this is the third video in the constant velocity series, where we're going to be looking at speed and velocity. These are two words that have different meanings within physics, and you're going to come across this quite often, is that words that in everyday normal people's language sound like they mean the same thing. In physics language, they have specific meanings and they mean slightly different things. So we're going to look at the difference between speed and velocity. So from last time, we've got our same red car that moves 100 meters, and we're going to say that that takes 10 seconds. So I've got my graph here of moving constantly 100 meters in 10 seconds. Okay, the gradient, which we talked about in the first video, is the speed. A steeper gradient is more speed, a shallower gradient is less speed. So we can calculate gradients. Gradients are rise over run, which you learned about in maths. And in this case, the rise is the change in position, and the run on our graph, our horizontal, is our change in time. So in this case, we have 100 meters divided by 10 seconds, that's 10 meters per second. There's a couple of bits here. 100 divided by 10 is 10, that's where the number comes from, but also look where the units come from. So meters divided by seconds, that's how we get our units of meters per second. So just like you can divide numbers, you can multiply or divide units, and that'll get us our final unit. Alright, so the gradient of this graph is the same everywhere. Okay, it is a straight line. That gradient has not changed. So sure, our car, its overall speed is 10 meters a second, but at any point along this graph we can say that the car is going at 10 meters a second because the gradient does not change. 10 meters a second is our constant speed. We could then do a speed time graph for this. So I've got speed on one axis here and time on the other. My axes would start at 0, and then up at 10 meters a second I do a horizontal straight line because the car's speed does not change from 10 meters a second at any point. I know that because on my first graph, my position time graph, my gradient is the same at each point. The slope of that line, that red line, is the same at all points, and that slope is 10 meters a second. So now that was looking at speed, let's look at velocity and how that differs. So now I've got a yellow car. This yellow car is now going backwards. Still takes 10 seconds to travel 100 meters, but going in the opposite direction. So on the graph, if it starts at 100 meters and ends up at 0, we get a line that looks like this. I can work out the gradient from that. So same thing, rise over run. The gradient is change in position divided by time. Now the change in position is a bit of a tough one. It is not 100. It doesn't start at 100 and get to 0, so it changes its position by 100. It's changed its position by negative 100. Okay, because change in position is always the final minus the initial. Its final position was 0 minus initial 100 gives me negative 100. Another way to think about it is if I started at 100, but my change in position was positive 100, I'd end up at 200. So the only way I can start at 100 and end up at 0 is if my change in position is negative. Do the calculation in there and my gradient comes out at negative 10 meters a second as opposed to positive 10 meters a second. And this is the difference between speed and velocity. Oh, how did that end? Velocity is a combination of both direction and the speed. So we've got our cars going at negative 10 meters a second. The direction is given by this negative. And the way you make sense of that is looking at our number line down the bottom. We start, or where the red car started, which is what I've called the start, that's my 0 point. All my numbers, 20, 40, 60, 80, 100, they are positive numbers. So if you imagine that's like a number line, to the right of the start is where the numbers are positive. If I was asked to draw on the negative numbers on that line, they would be to the left. So according to my number line I've got down here, to the right is positive, to the left is negative. This car is moving to the left, so it has got negative direction. This is the big thing in physics, is that we more often than not give direction. Instead of saying left and right or north and south or up and down, we often give direction as positive or negative. So velocity is a combination of that direction, the negative, and the speed, 10. So if I'd just written 10, that would be a speed, but negative 10 makes it a velocity. So here's my original speed graph from before. I'm going to put my yellow one on there, which had a negative gradient, which means I have to extend this speed graph down into the negatives and put my yellow one on there. Now that makes no sense because speed is only a number. This has to be changed to a velocity graph. So I've changed that word speed to velocity. That makes sense now. We've got positive or we've got negative. The red one was moving forward at positive 10 meters a second. The yellow one was moving back, and it was at negative 10 meters a second. Both of their velocities are constant though. So a summary of these two ideas that are very similar but different within physics. Speed, for example, 10 meters a second, it's just a number, no directions given. This is an example of what we call in physics a scalar. A scalar is when there's only a number there but no direction. Velocity, on the other hand, for example, negative 10 meters a second, gives a direction and a speed. Often in physics, our direction is given by pluses or minuses. Okay, and we're going to talk about that a lot more in the next video. This is an example in physics of a vector quantity. A vector quantity has a value, a numerical value like 10, and a direction. We're going to meet lots of vector quantities throughout physics. For example, force is another one, momentum is another one, and we'll go through them all. And the way we can calculate velocity was just the gradient of that graph, and the gradient of the position time graph is given by change in position over change in time.